slight, there's a slight difference in acid base. But we're not going to worry about that problem. But if I have, what did I just write here? Ammonium chloride. Oh, I was going to write one more word here. Strong acid, strong base. Ammonium chloride came from strong acid, weak base. What can you qualitatively tell me about that solution? Yeah, it came from a strong acid, weak base, pH less than 7. Or if I did, what's the other one? This came from a strong base, weak acid. I'm not going to write the different parts because I ran out of word space. Greater than 7. Okay. The other one, I used to do this derivation where I could talk a lot faster, and I could put more stuff on the board in a minute. Now I'm getting slower and slower. And it's not because of my arms, it's because I realized people didn't know what I was saying. I'd talk for an hour, I'd be finished, and people would wake up and go home, and next day I put on the quiz, they didn't know what was being done, so I don't do that anymore. But one of the ones I used to prove for you, which I'm not going to do, what do we do with ammonium acetate? Salt of a strong, weak base, weak acid. Well, after doing a bunch of simultaneous equations and some approximations, this is the Ka for the weak acid. This is the Kb for the weak base. Kw. This number is bigger than this number. In other words, it means the acid is stronger than the base. You get an acidic pH, something like a hydrogen ion less than, bigger than 10 to the minus 7. I gotta say this right. pH less than 7. If it's a reverse situation, you get the hydrogen ion. And lots of times people ask me about that because I used to put that sort of thing on the quiz 5, 10, 12 years ago. And so they come up with these old quizzes, and that was one of the problems I expected them to know about. This book doesn't talk about that. The book we used 25 years ago did. That's when I did the derivations, maybe longer. So that's the answer. I doubt if we'll ever use it in this class. Okay. Then if coming back to your question, how do you know? We're going to apply hydrolysis for salts. And I'm not going to ask you about salts of strong acids and strong bases, because those are the obvious. The obvious answer is pH 7, because there's no tendency for each of these to react with water to make the conjugate species. Whereas if I have something like ammonium ion, there is a tendency for this reaction to occur, and that's the problem we'll do the next time. But I set you up to do the problems. So they're all called hydrolysis problems. Questions? Did I take care of your question, or I just talked around it without answering it? What? You're good, okay. In other words, we're just applying this term concept of hydrolysis to salts. And this is the trivial case. I won't put that on a quiz. These are the two cases, the types of salts you have to worry about. I already took care of, what did I do here? There it is. This is the weak base, weak acid salt. This is the answer for calculating the hydrogen ion, except I'm not going to ask you to do that this semester. But if you look at some of the old quizzes, I think I updated my quiz set a few years ago, so that doesn't appear on my quiz. question? Now or never? All right, move on. No more questions? You have to do some problems, right? Next time I'll talk a little bit about polyprotic acids. I've said what I need to, well, I have to say something else. And then the next topic after that, I didn't turn this guy on.